How do you measure air temperature? You could go outside and listen to the crickets. American physicist and inventor Amos Emerson Dolbear discovered a relationship between the air temperature and the number of chirps a cricket makes. There's even a formula you can use. Of course, crickets aren't always available. The modern thermometer is much more reliable. But how do thermometers work, and how were they invented? The idea that things change when they are heated isn't a new one. Long before thermometers, blacksmiths and bakers would have needed an intuitive understanding of how the colour of metals or the texture of bread changes as heat is applied. The ancient Greeks knew that when air is heated, it expands. This idea allowed Philo of Byzantium to construct the first ever thermometer-like device in the 3rd century BC. A sphere containing air was connected to a jug of water using a tube. When placed in the sun, the air in the sphere expanded and released bubbles into the water. Cooling down in the shade, the air contracted and water rose higher in the tube. Handy for showing changes in temperature, but this wasn't a thermometer. Since it didn't include a scale, this device is more accurately named a thermoscope. The first attempt at measuring the temperature may have come from Greek physician Claudius Galenus. He mixed equal parts of boiling water and ice to concoct a neutral temperature. By then adding 4 degrees of hot and 4 degrees of cold either side of neutral, Galenus may have come up with the world's first temperature scale. It wasn't until Galileo Galilei in the 1590s that further progress was made. When he wasn't gazing into his telescope, Galileo applied his scientific vision to the thermoscope. Using the same ancient Greek principles of heat expansion to water and air, Galileo filled a glass bulb with air and attached it to a long tube of water. When the water warmed up, it expanded, and the level of the air in the tube fell. One drawback to Galileo's thermoscope was that it wasn't exactly portable. Its use of water meant that it needed to be very tall to detect small changes in temperature. It was also influenced by atmospheric fluctuations in air pressure. Galileo's fellow Italian, Ferdinando de' Medici, was also someone who knew what it felt like to be under pressure. Following the death of his father in 1621, Ferdinando became Grand Duke of Tuscany, aged just 10 years old. His unhappy reign of Tuscany was marked by a devastating outbreak of plague, economic decline, and a failed marriage to his first cousin. Little wonder Ferdinando found solace in new technology such as the barometer, hygrometer, and thermometer. In fact, in 1654, he constructed his own new and improved thermometer. Because Ferdinando partly filled his glass tubes with alcohol or urine instead of water, his thermometers could be much smaller than those filled with water and air. And he finally solved the problem of air pressure. By melting the tip of the tube, Ferdinando had invented the world's first sealed tube thermometer, independent of air pressure and complete with a handy scale. Although this wasn't the first thermometer with a scale, it was back in 1612 that Venetian physician Santorio Santori finally transformed the thermoscope into a thermometer by adding an arbitrary scale. The problem was several other inventors around this time also devised thermometers, and each had their own unique gauge. A consistent and reliable temperature scale was needed. Enter Daniel Gabriel Fahrenheit. There were more highs and lows in Fahrenheit's life than the temperature scale that still bears his name. Born in Gdansk in 1686, both his parents died from eating poisonous mushrooms when he was 15 years old. Sent off to work in Amsterdam as an apprentice bookkeeper, he hated his apprenticeship so much that he ran away several times, and a search warrant was issued for his arrest. Eventually, he settled in The Hague and worked as a glassblower, making barometers, altimeters, and thermometers. As a skilled craftsman, he was the first to use mercury in his thermometers, allowing the measurement of very high temperatures, since alcohol boils at 78.3 Celsius or 172.94 Fahrenheit. More significantly, Fahrenheit adapted a temperature scale previously devised by Danish astronomer Romer. The beauty of Romer's thermometer, which he invented while stuck indoors with a broken leg, was that it was properly standardized using temperatures found in the real world. Although he didn't write down his method, it's thought that Romer dipped his thermometers in a briny mixture of ice, water and salt to give him the most consistent 0 point. The freezing point of pure water became 7.5, and the upper limit of Romer's thermometer was found from boiling water set to 60 degrees, a convenient round number in astronomy. Fahrenheit didn't like Romer's fractions, and anyway, his mercury thermometers gave him enough precision to allow him to multiply the entire scale by around 4. With the freezing point of brine still set to 0, the freezing point of pure water was marked at 32. Add another 180 degrees and you get 212, the temperature of boiling water. Finally, Fahrenheit set human body temperature to 96 degrees and, among other things, used his wife's armpits to make sure that each of his thermometers was accurately calibrated. This was later adjusted to 98.6 degrees. The Fahrenheit scale is still used today in weather forecasts from the USA and some Caribbean countries. The standard elsewhere is the Celsius scale, named after Swedish astronomer Anders Celsius, who famously set freezing point as 0 and boiling point as 100. Or did he? Actually, no. Celsius' original scale was the complete opposite, setting the melting point of snow as 100 and the boiling point of water as 0. It's thought that he did this to prevent confusing negative numbers when logging temperature during the Swedish winter. Celsius died in 1744 and his scale was reversed shortly after his death. For many years known as the centigrade scale, it was established as the international standard in 1948 and named after Celsius. As well as Fahrenheit and Celsius, other temperature scales are still in use today. The Kelvin scale defines its 0 point as absolute 0, or minus 273.15 Celsius, the lowest possible temperature. Water freezes and boils at 0 and 80 degrees respectively on the Reumer scale, which is now mainly used in Italian and Swiss cheese production. And if all else fails, how can we forget the chirping cricket measure of temperature?